Okay, welcome back. This session I want to talk to you about part 2 of integration by parts. In this case I want to throw out an example which multiplies x times e to the 2x and show you the process that's needed to solve that one. In this case it's a mild introduction to how to put in the substitution rule into integration by parts. So with that I will just erase this and we'll get going. Okay, so the problem I want to solve, x e to the 2x dx. And if you remember the integration by parts, you're going to have the integration of f of x g prime x dx equals, and you need to have f of x gx minus the integral of f prime of x, and that is times gx dx. Okay, so with that, I'll keep that up in the upper right hand corner. And so we need to decide what is going to be f of x and what's going to be g prime. So if you look at this, you have f of x going in straight here, but you have f prime of x there. When you see an x sitting out here like that, it really makes good sense to say, I want my f of x to equal x, and my f prime of x will then become 1. So that works out very well in the second integral that you have in the solution here. So your g prime of x becomes e to the 2x dx. So then we just have to do a quick integral to find out what g of x is going to equal. So if I do a quick substitution rule here for that to get the integral of e to the 2x, if I substitute, make u equal to 2x, then du is going to be equal to 2 dx. And then I'll move the 2 to the other side, and so it'll be 1/2 du equals dx. So I can plug in to take the integral of e to the 2x dx becomes the integral of e to the u, and then I've got dx actually equals 1/2 du. The 1/2 just goes to the front, so we'll just have equals 1/2 of eu du. So the integral of that is just eu times 1/2, and then of course you have plus c. So that's what we care about right there. So then we plug, so we have 1/2, we plug in, resubstitute u to x is 2x. So pretty obvious once you look at it, because if you take the derivative of that, you'll get rid of the 1/2 and everything works out just great. So 1/2 e to the 2x. So I've just made all of my decisions right here for everything that's going to fill into the formula for integration by parts. So let's work the problem over on this side here. So we have the integral x e to the 2x dx equals, and then we need f of x and g. So x times 1/2 e to the 2x, okay, minus the integral We have f prime, which is just 1, and then we have gx, which is 1 half e to the 2x dx. This dx actually comes from right here. Okay, so the 1 will go away and we'll just be left with solving that. So let's continue down. So I'm just going to rearrange this front one a little bit to make it a little neater. 1 half x e to the 2x minus, and then I'm going to pull the 1 half out to the front. That's an e right there. The integral of e to the 2x dx. And if you were paying attention right here, I already did the integral to get that. So this right here is going to become this integral here. So I'm going to have the 1 half come down, and then I'm going to have another 1 half e to the 2x right there. This is minus, and then another 1 half x e to the 2x dx. Okay, so a little bit of simplification here. This becomes 1/4 e to the 2x 1 half and looking at this a little bit better, a little bit more, I probably could have just said 1 half e to the 2x x times 1 half. That looks like a nice answer right there. Okay, so you can see a simple application of the substitution rule here, and then you can see how we just apply the integration by parts formula and we get right down to our answer there. So piece of cake, right? Okay, good luck. There'll be many, many more parts for integration by parts. So keep an eye out for that. We have a lot more to add in, such as trigonometry and that. So it's a very in-depth subject. This is just the next step. So good luck and hope to see you soon.